All right, so we're going to look at some simple parametric objects. And if you remember from class, what we were talking about is the idea that what Grasshopper allows you to do, what I'm interested in doing with it, is it allows you to define the relationships between things and then sort of specify the details and change them later. So if you remember, parameters hold things and components do things. And I always start off with a point parameter, and I always change the name of my parameters, but I never change the name of components because you want to know what components do and you want to know what parameters hold. So I always start out with a point parameter that holds the origin, and we could create some Rhino geometry and reference it in, or we could use the point component, which takes an x, y, and z value, by default 0, 0, and 0, and um, and creates a point. So here, I'm just like turning the grids off, F7. Um, okay, so in this case, what if we want to start by specifying the height of our object? Like that's the fundamental parameter, height. And we could do that. We can get a slider, double click, and we can put a domain on the slider just to parameterize how it works. Let's say it goes from 1 inch to 12 inches. We only want integers. Cool. And now what we're going to do is we're going to draw a line that's going to be the central axis. And we're going to do that by getting a z vector, which by default creates a unit vector, which is just essentially a line with a direction, in this case z, pointing straight up. We're going to hook the height up to it. So now it's got a magnitude of whatever our height is. And next we'll get a transform. You can sort of double click and search, which is my preferred workflow. We're here in the transform, right? It's useful to go through all these until you know what's exactly in them. So this says, you give me a piece of geometry, like a point and a vector, and oops, what is, ah, what's going on here? Oh, sorry. Wow, it must be early. What I meant is not transform, what I meant is move. Move component. I have been using too much Touch Designer lately. Um, and although move is a transform, in this case, not all transforms are moves. So a move vector. So you give me a piece of geometry and you give me a vector. See what the transform did. Just transform asks you for a set of transform parameters, which is a sort of a different way of manipulating geometry. What we want is move. All right. Okay, there we go. So you can see, right, that's my um, that's my new geometry. And very often I like to dump that out to a parameter, and I'll say, I don't know, top point. Um, something else that's useful, I think, is when you get a, a bunch of stuff that does something important, group it. You can also right click and you can give a title to that group and say, create main points so that later you can read your definition. You come back to it like a month and you're like, what does that do? Now you know. The other thing that I think is really useful is to celebrate by saving. So let's just actually, no, I'm just going to put this on the desktop. You would save it somewhere important. And the other thing I'll do sometimes, right, is just to keep things clean is, right, send my parameters to other parameters so that I could go over here and now say, let's create a line. So we get a component, it says you give me a point, give me another point, I'll give you a line, right? And the output of this is not a new point, right? It's a curve. And we can get a curve parameter with there, and we'll call this axis. All right. So next thing we want to do is we want to say, what if we wanted to make um, our profile curve always relative to this axis, right? And that will have some distinct advantages. So one thing you could do is you could say, I want to create a point along that line, and you could do what's called evaluate the curve, just somewhere in here. Evaluate curve, right? And evaluate curve takes a curve and a parameter, and what the parameter is it's like saying it's like a number from 0 to 1. First thing you do is you say, I want to reparameterize this curve, which means I want you to think of it not in terms of its length, right? In this case, its length is 6. And you could say that right here, that's 0 from the origin, that's 6 from the origin, the middle is 3 from the origin, but what if it changes, right? 6 from the origin is still here, but now this is 9 from the origin. But what if we always wanted to talk about the top or the middle, or 25% of the curve? So when we say reparameterize, right, we click that little guy. It allows us to treat the curve as if the origin is always 0 and the end is always 1. Um, and then, right, we can come up with a parameter and we can get a point, right? And so right now that point is a quarter of the way up. We set this to be, 0.5, right? It's halfway up. And it doesn't matter what happens to our curve length, right? That, because we've reparameterized it, we're treating it as uh, from 0 to 1. We're understanding this as a percentage. And, if we had like a more complex curve like that, just make it so you can see this here. And we wanted to, let's say, set one curve. Oops, there we go. Right, if we wanted to do the same thing with that curve and we say reparameterize, right, we get the same thing, right? Here's point 0, there's point 1, right? Doesn't matter if it's a line, if it's a curve, whatever. Okay, so um, now for each point, we also want to move it in X because we're going to start to form the profile. So we're going to go again and we're going to get this time we're going to get a unit X vector. We'll call this, we'll rename that parameter and we'll call it param on curve. And I'm just going to copy this and we'll call this dist from axis. Let's call this param on axis. How about that? That makes sense. And we'll say, um, right, we'll say a minimum of 0, a maximum of 12. And this time I'm okay with it being real numbers. So we can have decimal points. Right. And this time we're going to remember, we're going to move, not transform, move. We're going to move that point. and we're going to move it according to this, right? So now, right, this is what we get. And if we want, right, something that's really useful is to turn off geometry sometimes when you don't want to see it. Like we don't really need to see this interim point. Maybe, maybe it's useful to you. I don't know, but all right. So, um, and then this we're going to call our we're going to call these our profile points. So one thing we could do when we did this in class is we copied this whole thing, right? So we could get a series of profile points. That gets a little ugly, right? So what we're going to do instead is we're going to use Grasshopper's ability to deal with lists of things. So, right, I'm just going to copy, oops, if you hold, you have to hold down Shift, right? Let's do 5, maybe. And do the same thing here. Right? And so you'll see now, right, what it means is if I mouse over this, right, this now holds a list of floating point numbers, and you can see that that is not a single line when you have one value, like coming from the slider, but it's now a double line when you have a list. Um, and you can also see, right, what happens if here we have a list of 5 numbers, so we're getting 5 points. All right, we'll turn those back on for a second. And you can see what it does when it has a list of 2 different numbers, right? Here we got 5 points, but here we've got only 2 vectors. So it says it uses the first vector with the first point, and then it keeps using that 6.7 with the rest of them. So, right, if we want to change that, right, see, we can hold down Shift, hook that up. Cool. All right, so now we've got 5 values along this axis, right, starting from 0% of the way to 100% of the way. We've got 5 different x vectors to move it off the axis, and then we get 5 different points. And so finally, the last thing we can do, right, is we can use this component, which says, give me a set of points, and then the rest, you can leave the default value for the rest of these inputs, and I leave that for you to explore on your own. And you can see what kind of curve you get with the interpolate curve, right? It puts the curve through each of those points. There are other ways of doing this. You could use the NURBS curve, which treats each of the points as control points, right? And you can see that gives you a much smoother curve, but you don't necessarily, where you're using these as control points, but you're not necessarily passing through those points. Right, let's make it closed at the bottom, maybe. So let's put that down there, right? And then, right, the last thing we can do, right, and this is also a great place to celebrate by saving to, let's see, the output, we'll call this profile I like to have no spaces, although you can have spaces. It doesn't really matter. Profile curve, right? And maybe we'll group all that. Right, and then the last thing we'll do is like, let's rotate that profile curve around the axis. So revolution, right? It says you give me a profile curve. Let's do this. Give me an axis. Got an axis over here. This is just our line. Right, and I very often like, sort of sending parameter to parameter and moving them to be next to the components because I find it ultimately makes it easier to read later. All right, let's say, let's add like maybe like one more uh, point. There we go. Very elegant. Love it. Right, and then the last type of parameter that we'll use here is we'll use surface parameter. Right, now remember, if we want to get grasshopper geometry back into Rhino, we have to bake it. But once we bake it, it loses all of its ability to change. Shaded, shaded, right? And so what's super cool about this, right, is now, we have a set of relationships that define the profile curve that are all relative to the axis, and the axis is controlled by height. So if we wanted to make like the tall version of the same thing, all we need to do is up the height and everything changes proportionally. Right? Or if we wanted to make the really squat version, right, we could do the same thing. Now, right, what I leave it up to you to do is to think, right, this is a very particular set of relationships where we say, you know, each of these points, actually that's really ugly. So let's at least make it taller before we go back to messing around with it. Right, right. Each of these points that we created, each of these points, and then each of these points is relative to the axis, right? But they're independent of each other. Meaning, if I change this point, right, it doesn't change any of the other points. So one of the things we did in class is we looked at a way in which you could, let's say, create a different definition where each successive point is based on the previous point. But here's something we didn't do. What if we decided we wanted to be able to change this whole curve sort of proportionately? Um, well, one thing we could do right here, we just have a bunch of numbers which define its distance. We could just do a little bit of math. We could say, what if we want to multiply that by a scale factor? Let's make the top value 2. Right, so now we're taking all of these, each of these, 0, 3, 4, whatever, and we're multiplying them by a scale factor. Right? So now this is a way of changing the sort of relative width, slenderness, without changing the relationship between points. So we could do something like this. We could say, let's see, for a really tall one, there's, skinny, the medium, and the wide. Right. So now we have a different set of relationships. Um, right. Uh, let's do one more thing. Um, right. Uh, what if, um, what if we took this number and we said that there was always, I don't know, I've never done this before, so this is a little bit of an experiment. Um, what if we said, uh, it's always kind of a relationship to the height. Let's see what our output is here. Actually, let's, instead of, let's do a division. Say the height divided by some number. Let's make this go up to 20. Make this go up to 50. What if this were our multiplier? Oops, what happened here? Oh, sorry. What we want to do is make this be the multiplier. Oops. Let's take that again. Right. We want to multiply this number by this factor. And this factor is determined by our height partially. There we go. Right. So that means, right, actually we want to multiply it by our height and we want to multiply it by, no, that's right. Um, actually, this is no different than what we had before mathematically. Never mind. Let's forget about this example. Um, that's what I get for trying to freestyle in a tutorial. Um, yeah, much more useful this way. All right. In any event, uh, you can play around, and in fact, that's what I've asked you all to do for Wednesday. Um, enjoy.